Hi everyone, so I'm going to take you through worksheet number 3, just so that you have a better idea of the solutions just in case you were struggling with these problems. Okay, so we have a rectangle, has its base on the x-axis and upper two vertices on the parabola, y equals 12 minus x squared. So there's our parabola, and we're making a rectangle. Not a very good rectangle. What is the largest area of a rectangle? So the area of a rectangle is length times width, right? So length or width, so this is the distance for the bottom, right? So what would that be? Well, if this is x, this is x. Don't worry about one of them being negative because we're talking about distance, right? So 2x times, and then we need this height. What is this height? Well, if this distance right here is x, this point right here is x comma the function. That means the height of the rectangle is 12 minus x squared, right? We think of it as just the y value, but it's also the y is the vertical distance, right? If I plot the point 2, 3, this distance is 3, right? All right, so now we're gonna, maximize? What is the largest area? Maximize. So distribute. Maybe distribute correctly. Make that a 24. My eraser working. Eraser. My eraser is not working. What is happening here? All right, so 24x minus 2x cubed. There we go. A prime, take the derivative, set it equal to 0. 24 minus 6x squared. Set that equal to 0. So let's see, x squared equals 4, so x equals 2. So that means the entire bottom, that distance is 4. And then the height will be 12 minus 2 squared, 8. So 4 times 8, and the area would be 32. All right, write a formula for the volume of the box. So volume is length times width times height. So remember, we are shaping this thing into a box. Now, unlike the other ones, this one's a little more complicated because it has a lid, right? So the easy one is the x, right? The other one that's not so bad is this distance, right? So since this entire thing from here to here, the whole black is 10, I have to take off the 2 red pieces. So that's 10 minus 2x. Well, that's actually 10 minus 2x over here. The difficult one is this guy right here, because this whole thing is 15, but we also have a lid, right? We have that lid, which is the same distance. So the whole thing is 15. Take away my x's. So 15 minus 2x, but then we have the base and the lid, so then divide by 2. So my formula is all of that multiplied. Right? X, 10 minus 2x, 15 minus 2x all over 2. I think what I did to make this easier is I divided. So I made it 10x minus 2x squared times 7.5 minus x. And this is what I took the derivative of to maximize. So v prime, derivative of the first, 10 minus 4x times the second, plus the first, derivative of the second is just a minus. And then I FOILed and simplified. When I did all that, I'm just going to skip and show you that I got, that's the derivative. I ended up getting 6x squared minus 50x plus 75. So that x was 50 plus or minus the square root of 700 all over 12. And then I just used the calculator. There's 2 answers, but the 6.371 doesn't make sense for the problem. that would make the base, right? If we're do 10 minus 12 point something, that makes no sense. So I got x is 1.962, and my volume was 66.019. All right, what is the maximum area of a right triangle with a hypotenuse of 10? So this goes back to the kind of formulaic ones where create a function, create an equation, substitute, solve. So we want to maximize the area of a right triangle. So here's my right triangle, A, B, and then it gives me a hypotenuse of 10. Right? What equation do we know that involves A, B, and 10? A squared plus B squared equals C squared. We're also trying to maximize area. Area is 1/2 times the 2 legs. So pick either A or B to solve for, doesn't matter which. I'm going to solve for B. So B is, and I actually don't need the C squared, I'm going to make that 100, 10 squared. 100 minus A squared, square root. So then my area formula is 1/2 A times the square root, 100 minus A squared. That's my function. Now this is what I'm going to maximize. Take the derivative, set it equal to 0, do all the things. So A prime, it's a product rule, derivative of the first times the second plus the first derivative of the second. Derivative of the square root is 2 times the square root. And then I need the derivative inside, negative 2a. So I'm going to go through, see what I can simplify. Let's see, so I get the square root of 100 minus a squared all over 2 minus a squared over the square 2 times the square root of 100 minus a squared equals 0. To solve this equation, I need a common denominator. So this left one gets multiplied by 100 minus a squared. So that ends up just squaring the top. So we have 100 minus a squared all over 2 equals 0. We can kind of ignore setting the bottom equal to 0 because you get 10, right? But the sides aren't, that would make a area of 0. Like that would make the side 0 and it's not a triangle. So I'm not going to worry about that. I'm going to go up here. So 0 equals 100 minus 2a squared. A squared is 50. So a is the square root of 50, which is 5 root 2. If the a is 5 root 2, then b would be 100 minus 50, which is, it actually ends up being the same thing. Square root of 50, which is 5 root 2. So the area would be 1/2 a times b, 5 root 2, 5 root 2. So that gives me 2, the square root, 25. So my area is 25. And that's it. All right, a rectangle inscribed between the parabola 4x squared and 30 minus x squared as shown below. What is the maximum area of such a rectangle? So I'm going to draw in my rectangle. So it's going to be something like this. Really terrible drawing. Okay, so now one important point is that both of these are symmetric to the x-axis, right? 4x squared, its vertex is here. 30 minus x squared, vertex there. That means that this is, if this is x, if this distance is x, then this distance is x. That's really important. We really can't, it would be really complicated to do this otherwise. So just like the other ones, that distance is 2x. So area is 2x, and then times what is the height or width, whatever you want to call it, of this. Well, that's just the blue minus the red, right? Take the blue, this whole thing, take away the red, we are left with that distance, green. Blue minus red equals green. So that is 30 minus x squared minus 4x squared. Right? So then that is our formula that we're going to maximize. So let's simplify it. 30 minus 5x squared, 60x minus 10x to the third. That's my area. Take the derivative, set it equal to 0. 0 equals 60 minus 30x squared. X squared is 2. X is root 2. Let me just check my work. Yep. Okay, so then a rectangle, what is the maximum area? So the maximum area would be 2 root 2. Right, I'm just going to plug in this. 2 root 2. I wrote 2 root 30. 2 root 2 times 30 minus 5x squared times 2. 2 root 2. 30 minus 10 is 20, so 40 root 2 is my answer. All right. This one, if you had trouble with any of them, my guess is it's this one. We haven't done one like this. A piece of wire 40 centimeters long is cut into 2 pieces. So this whole thing is 40, and it's cut into 2 pieces. One piece is bent to form a circle. The other is bent to form a square. Find the length of the 2 pieces that causes the sum of the area of the circle and the area of the square to be a minimum. So if you've never seen this before, it's I would say it's pretty tricky the first time I did it. So first off, I'm going to name these x. If this distance is x, this one's 40 minus x. Now, what are those 2 pieces of wire in terms of the square and the circle? So if we're going to bend that distance into a circle, that's perimeter. So that means my perimeter of a circle, which is 2 pi r, is going to equal either x or 40 minus x, whichever one you think will be easier, however you want to do it. I said this was x. That means, and then think about why that's important. What are they asking me to maximize? Area. So I'm really looking at the area of the circle. So if I solve for r, because I need the area of a circle, I get x over 2 pi. Now I have a square. What do we know about a square? Well, the perimeters are all the same. Say s, right, side 4s equals, what's the other piece? 40 minus x. That means one side is 10 minus 4x over 4, or if you just want to leave it 40 minus x over 4, it doesn't really matter. I think I put it like that. So now we have the side and we have our radius. All right, so my radius. If that's my radius, what's the area of my circle? All right, the area of a circle is pi r squared. But we figured out something for r, x over 2 pi. And then we want to add to that the area of the square. How do you find the area of a square? You just square the side. 10 minus x over 4 squared. That's our formula that we are going to maximize. I'm going to simplify it before. I'm going to leave the right one by itself, but the x squared over 2 pi one. So when I simplify that, that cancels out with the square. So I get x squared over 4 pi, and then my 10 minus x over 4 squared. All right, I'm going to take my derivative, set it equal to 0. So we get 2x over 4 pi plus, bring the 2 down, times the derivative of the inside. So x over 2 pi when I simplify, pen turned off, 2 pi minus, let's see, it's a 2, I get negative 10 no, I just confused myself. Got 1/2, I'm just gonna write it out like this. I don't want to get confused. Why isn't my pen working? Oh, it's on eraser. 1/2 10 minus x over 4. Okay, so that's x over 2 pi minus 5 plus x over 8. Ooh. So I'm going to bring the 5 over. 1 over 2 pi plus 1 over 8. Well, that's not nice. All right, I think I'm just going to stick this in the calculator. That is not what I had when I did this before. I mean, it's probably the same. My answer before just looked different. Okay, so I ended up getting 17.596 for x. So that 40 minus x was 22.404. Yeah, I simplified before. All right. A manufacturer wants to design an open box having a square base, surface area of 108. What dimensions will produce a box with a maximum volume? This one shouldn't have been overly difficult. All right, design an open box having a square base. So the base is square, and the height is not necessarily square. It's a box. Surface area is 108. So surface area is 108. So we need to figure out what's the surface area of our box. So this side has an area of x times y. Oops. And then how many of those are there? There are 4 of them. There's each one on the outside. So I get 4xy plus the bottom. The bottom is the one that's a square. Bye. Right, so that's my equation. What dimensions will produce a box with a maximum volume? So now this is one we need to solve for one of the variables. So I'm going to solve for y. 108 minus x squared all over 4x. We are what are we maximizing? Volume. So that is x times 108 minus x squared all over 4x. Let's simplify this. 108 x squared minus x to the 4th over 4x, which is 108x minus x cubed all over 4. All right, so that is what we are maximizing. Nice, easy derivative. This is not a quotient rule because the bottom is just a constant. So 108 minus 3x squared all over 4. So 108 minus 3x squared. The 4 will just disappear. So x squared equals 36, so x is 6. What dimensions will produce the maximum volume? So 6 by 6. The y value is 108 minus 36 over 24. That's 72 over 30 over 24, which is 3. And that is my volume. All right. This is an easy one. You should have been able to get this one without too much trouble. A gardener wants to construct 4 garden areas by first building a fence around a rectangular region and then subdividing it into 4 smaller rectangles. So 1, 2, 3, 4. By placing 3 fences parallel to one side, what dimensions of the region maximizes the amount of fencing if the total area of the region is 300? So there are multiple ways to do this. This is how I do it, though. I'm going to make this side y, and then all of these sides x. So that the area of the entire thing is xy. the total area of the region is 300. Otherwise, we'd have like we'd have a number in there, and I think it just makes it easier. So the total area is 300. So I always solve for y, so the y is 300 over x. We want to minimize the fencing. So the fencing is 1, 2, 3, 4, 5x plus 2y. But we're going to substitute in 5x. The y is 300 over x. That gives us 600 over x. Take the derivative, set it equal to 0, 5. And again, this is why I told you to memorize the derivative of 1 over x. It's -1, so negative 600 over x squared. Set it equal to 0, common denominator. We don't have to worry about the denominator equaling 0. It's the real life problem. We're not going to have 0, right? That makes no sense. So then x squared equals 600 over 5, which is 120. So x is, what's 4 times 30? 2 root 30. What dimension? The region minimizes what dimensions? So x is 2 root 30, and y is, let's see, 300 divided by 2 root 30. √30 over 60, 5 root 30 is the answer. Those are the dimensions. I didn't do it, but if you want to check the second derivative, f double prime, derivative 5 goes away, derivative of negative 600 over x to the second becomes 1800 over x cubed. That's greater than 0 when you plug a positive in, so this is going to be a minimum using the second derivative test. Last one. So again, we're kind of ending on easier ones, which is nice. A 216-meter rectangular pea patch is to be enclosed by a fence and divided into 2 equal parts. So we've got our pea patch, 2 equal parts. What dimension for the outer rectangle will require the smallest total length of fencing? How much fencing will be needed? All right, so I've got my x, my y, and it's giving me an area, xy, of 216. This is literally just like the last one. 216 over x. So we want to minimize the fence again. F equals 3x plus 2y. Substitute in. What's that? 432 over x. When I substitute in for y, take the derivative. Set it equal to 0. So 3x squared minus 432 all over x squared. So we end up with 3x squared minus 432. 432 divided by 3. What's that? 144. So x is 12. How much fence will be needed? So y would be 216 divided by 12. I don't know. What is 216 divided by 12? That's 108 divided by 6. 18. What dimensions? So these are the dimensions. And then how much fence will be needed? So we need 3x, so 36. 2y plus 36 is 72 meters. That's it. All right, so hopefully that helped. Of all these problems, I honestly think the one that was the most difficult would be the one with the piece of wire, just because we've never seen one like that before. Maybe number 3, if you didn't think of the Pythagorean theorem, But most of the other ones, we've done similar ones, and you should have been able to do. We're going to do one more day on optimization, and then we're going to review, and then the test. Email me if you have questions.